All right, so new problem. How many different ways could I seat 5 people at a circular table? This is another application of the same strategy where we'll list all of the ways, but then we'll divide by the number of ways that really should be treated as the same. So here's the thing about a circular table. Let's say I sat my people down like this, A, B, E, D, C. If I sat my people down this way, C, A, B, E, D, it's a different way of seating them insofar as, like, if I'm listing this as chair number 1, this is chair number 2, there's different people sitting in each chair. But from the perspective of the people, A is sitting next to B and C, and here A is still sitting next to B and C, so it's just that everybody's rotated. So I think that these two seating arrangements shouldn't actually count as different because the only thing that's changed is everybody's rotated, but everybody's still sitting next to the same people. So if that's the way I'm thinking about it, I know there's 5 factorial ways of putting people in the seats, but for each way of putting people in the seats, I have to divide by how many different rotations are equivalent. So if I have this ordering, A could be here, or I could rotate everybody so A is there, or here, or here, or here. So that's 1, 2, 3, 4, 5 different ways to rotate the same ordering. So I'm just going to divide by 5. Not 5 factorial, because first of all, that would just be 1. But second of all, 5 factorial is the total number of ways of reordering 5 things. I'm not interested in all of the possible swaps I could do. I'm just interested in dividing through by the rotations, the number of rotations, because the number of rotations are the total number of things that should count as equivalent. So in general, if you had n people, you'd have n factorial ways of seating them, and you'd divide by n rotations that should count as the same. But I should point out that it's all about what you want to count. You drive the math. The math doesn't drive you. I said that the rotation should count as the same. Well, what if you're not in the middle of the ballroom? What if, and it's like one table by itself, what if there's like a window with a nice view here? Then being in this seat isn't the same as being in this seat. In this seat you have a nice view out the window, and in this seat you don't. It's to your back. So in that situation, you wouldn't want to count rotations as the same. And so in that case, you really might say that there are just 5 factorial different seatings. So I want to emphasize in all of these problems, it's about what you want to count as different. And that's what dictates the strategy, and that's what dictates the answer. Okay.